Second graders. I'm Miss Jackson Smith, and this is a second grade math video. This video goes with the Google Classroom work that's for Thursday, April 16th. And in this video, we're going to practice a little bit of subtraction, and then we're going to keep working on symmetry. And I have one new thing to teach you guys about symmetry today, and I'm really, really excited about it. But first off, before we really start and get into it, I want you to make sure you have all the materials you need. For this video, you're just going to need a piece of paper and something to write with and your brain. All right, here we go. First off, let's review some addition and subtraction with regrouping. On this page, I gave you guys an addition problem to practice what we worked on yesterday with adding three big numbers. And then I gave you a subtraction problem, and we're really going to focus on the subtraction problem for today. Let's go ahead and sing our addition and subtraction songs. First, let's start with our addition song. Add, add it up. 9 or less, let it rest. 10 or more, go next door. Then for subtraction, we say more on the top, no need to stop. More on the floor, go next door. Take 1 10, that's 10 ones more. So let's use those addition and subtraction songs to help us remember our rules for regrouping for our practice today. Go ahead and copy down these problems, try them on your own, and then when you're ready to try them again with me, just press play. All right, I'm going to assume that you're ready to try them with me. Let's take it one step at a time. Let's start with our addition problem. Over here, I'm going to start off in the ones place. I see the addition sentence, 2 plus 3 plus 0. And so 2 plus 3 is 5. And then if I add 0 to that, well, that's just still 5 because 0 is basically nothing. So I'm going to write down 5 in my ones place. Next, let's look in our tens place. What's the addition sentence in our tens place? It's 3 plus 4 plus 9. I'm going to think about 3 plus 4 first. 3 plus 4 is 7. So I'm just going to pretend that this problem's really 7 plus 9. 7 plus 9 is 16. So I'm going to write 6 tens and carry 1 100, just like that. All right, next is our hundreds place. Let's look at all the digits in our hundreds place. We have 1 plus 4 plus 2 plus 1. So I'm going to group those by thinking about 1 plus 4 first. 1 plus 4 is just 5. And then I can think about 2 plus 1, that's 3. So you can really think about this as 5 plus 3. You might have thought about it a different way, and that's okay, but I just thought about it as 5 plus 3. I know 5 plus 3 is 8, so that's 8 hundredths. All right, let's move over to our subtraction. I wonder if you remember where we have to look in our subtraction problem when we start. We're going to look in our ones place. And I want you to look at these two digits in our ones place and think, is there more on the top or is there more on the floor? 6 is more than 3, and so there is more on the floor. When there's more on the floor, we go next door. In next door, it's the tens place, and so we're going to take 1 10. And so we had 2 tens, but we're taking one of them and unbundling it into 10 ones. So I take 1 10, and that means I have 1 left. And now I have 13 ones instead of 3 ones. So now I have 13 minus 6 in the ones place. 13 minus 6, that's 7. And then I'm all done in my ones place. I'm going to go look at the tens place. In the tens place, I have 1 minus 8. Is there more on the floor or more on the top? 8 is 8 is on the floor, and 8 is more than 1. So that means there is more on the floor. When there's more on the floor, that means we need to go next door because there's not enough to subtract that many. So I'm going to go next door to our hundreds place. In the hundreds place, I have 8 hundreds. So I'm going to take one of those hundreds and unbundle it into 10 tens. So now I have 7 hundreds left and I have 11 tens instead of 1 10. Now that I have 11 tens, I have enough, and so I'm ready to subtract. 11 minus 8. 11 minus 8 is 3 tens. So I'm going to write a 3 in my tens place. And last, I just need to look at my hundreds place. In my hundreds place, I have 7 hundreds minus 3 hundreds. 7 hundreds minus 3 hundreds, I can just think about what would 7 ones minus 3 ones be, and it's just the same. It's 4. So it would be 4 hundredths. That is all of our addition and subtraction for today. You guys did a fabulous job, and we're going to keep working on addition and subtraction in our next video too. But I've seen on your Google Classroom work you guys are working so hard and you're getting so good at adding and subtracting, so I might need to think of something that would be even more challenging. I'm not sure, but let's just wait and see. So let's move back into thinking about symmetry. First, you want to remember that a shape has line symmetry if it can be folded into a line that has its 2 parts match up exactly. And in your online work, I saw a lot of you guys say on your exit ticket on Wednesday that it had to match up perfectly. And I really like that you guys are being so specific that those edges in every single place, if we pretend in our mind to fold it over, they would have to line up exactly. If they don't line up, then the line isn't in a place where it's symmetrical, all right? That might mean you just have to move the line to a new place, but it might mean that then the shape is not symmetrical, okay? So for a line to be a line of symmetry, it has to divide that shape into 2 equal parts that are congruent. That means they're the same size and the same shape. If they're the same size and the same shape, then when we fold them, they should line up exactly right. Let's take a look at these examples of symmetry again. I want you to look first at all of the ones on the left side over here. Look at each line of symmetry, and in your mind, I want you to pretend folding that shape on that line. And I want you to imagine those corners, like these corners right here, lining up exactly right when you fold them, all right? Now let's look over on this side. These are non-examples, and non-examples means, in this case, that they're not lines of symmetry. Let's look at this triangle. If you pretend in your mind that we're folding this triangle across this vertical line, this side right here would fold over and this top point would poke out up here and it wouldn't match up right here. So that would mean that that's not a line of symmetry because if we fold it, the parts don't match. Same thing on this parallelogram. A parallelogram is a big word, but you might have heard it in first grade, but it's one of these shapes that looks kind of like a square, but it's leaning over to the side. And on this shape, if we fold it on this vertical line, we could try and fold it, but the parts wouldn't match exactly. Because if we folded this part over here, it would poke out right across this side, and so they wouldn't match exactly. This week we also learned that there are some other words we can use to talk about our lines of symmetry. If a line of symmetry is going exactly side to side, it's horizontal. If a line of symmetry is going up and down, like a column, it's called vertical. But if a line of symmetry is not going totally vertical or totally horizontal, but it's somewhere in between, and it slants kind of like a slide, it's called diagonal. But wait, there's more. Some shapes are not symmetrical. That means we could say that they have 0 lines of symmetry. Like this. This monster has 0 lines of symmetry. There's no place, not vertical, but even if we went horizontally or diagonally, there's nowhere we could draw a line where both sides would match. Some shapes are symmetrical and they have exactly 1 line of symmetry. Like this shape. This butterfly has 1 vertical line of symmetry, but if we drew that line across horizontally, it wouldn't be symmetrical that way. It's only symmetrical vertically. But some shapes have more than 1 line of symmetry. In our slideshow yesterday, we looked at this clover. This clover has not just 1 line of symmetry, but we saw that there's all these other lines that also work. So our job today is to count the lines of symmetry in a shape. Your first step is to try a vertical line. So first off, I tried a vertical line going straight up and down, and both sides match exactly, so the vertical line worked. Now let's try a horizontal line. The horizontal line If I folded over that side, do you think that those sides would match? I don't think so. Both sides are not equal. They're not the same size and same shape, and they would not match exactly if I folded them. So the horizontal line did not work, but the vertical line did, right? Now let's try a diagonal line. In my mind, if I fold over this line, I think that it does work. Both sides look exactly the same size, and I think that both corners would match up. So that diagonal line worked. But there might be more than one diagonal line of symmetry. So you want to rotate this line in your mind and think, are there any other places I could put this line that would work? So we already had a vertical line. We have one diagonal line. But if I put the line here, it also works. So that means there's two diagonal lines that work for this triangle, because both sides would still be equal. They'd still be the same size and shape. So in all, on this triangle, there are 3 total lines of symmetry. There's one going up and down, and then there's 2 diagonal ones. So this triangle has 3 lines of symmetry. All right? So now it's your turn. We're going to try this one. You're going to look at each shape I show you, and you're going to count how many lines of symmetry the shape has. And I wonder, can you find them all? So here are these shapes, and if you want to, you can draw them onto a piece of paper, or you can just look at your screen and hold up your finger or hold up your pencil, but be careful not to write on your screen, and move that straight object around to see if you can find any lines of symmetry. I want you to pause the video and see how many lines of symmetry you can write for each shape, write them down, and then press play to find out how many lines I found. All right, let's check your work. On this square, I'm going to start off with the square. The square has one vertical line, one horizontal line, so now we're up to 2 lines. This diagonal line works, so there's 3 lines. And this other diagonal line works too, so there's 4 lines. So the square has 4 total lines of symmetry. Next, let's look at the heart. The heart has one vertical line, but if I try to draw another line, there's no other place that I could draw it. So the line only has one total line of symmetry. On this star, if I draw a vertical line, that works. But it also works like this on this diagonal, so now we're up to 3, 4, and 5 lines of symmetry. So if I draw all of them at once, they look like that. Wow. You guys did an amazing, amazing job. And your next step in working on symmetry and working on adding and subtracting is to go to Google Classroom and complete your math work for Thursday, April 16th. I had so much fun working on this video, and I'm really excited to give you guys a bunch of shout outs tomorrow for all of your hard work on math this week. I've been having a lot of fun learning about symmetry, and I'm just excited to keep learning with you guys on YouTube and Google Classroom. I love you guys so much, and I will see you again soon. Bye.